All right, the blue one and the green one are inverses because they're a reflection over the line y equals x. That's one of many concepts that we taught you in this unit. Okay, what's the one from yesterday? I gave you a function, then you had to find its inverse. All right, and what was the one thing I said was really important about inverses? What switches? X and y, and therefore the domain and range would switch too, right? All right, so let's say I had something, and this f of x, I'm not even telling you what it is, but its domain is from 0 to infinity, and its range would be all reals. Do you get that if I got its inverse, just to clarify, this is the symbol for inverse, f negative 1. That's saying inverse. The inverse of that other function, what's its domain and range then? Don't say it, write it. Some kids are not processing this, and they need to learn it now. Domain and range. You don't even need to know the function, or you don't even need to know what the new inverse function is. You should be able to say what its domain and range are. What's this domain right here? All reals, because it came from the range of the original. And the domain switches to the range, and that would be 0 to infinity. Okay, now, if I give you a picture, and I've said, here's a graph. Is that the line y equals x? No, it's not. Let's say the line y equals x runs right here. Graph its inverse. These can be tough to visualize. So make up a few points. Like, I don't know exactly what that is. Could I say it's 0, 3? Sure, I could say that. Or 0, 4 or 0, 2 or something like that. And then you can take points and like reflect those points to make sure you've included it. Like, okay, then if 0, 3 must be on this graph, then 3, 0 must have been on the other graph. You get what I'm saying? Okay, and then how about this? Do you get how it's almost touching here? So then this inverse, let's say I'm going to make the inverse red here. The inverse would almost touch the line like that across the line from it. And then I'm going to go like that. Did you say something like that red line? Raise your hand if you did. Okay, awesome. And you know how to make an inverse picture-wise. Let's see if you know how to make an inverse from an equation. Find the inverse of that. I've already done the first step. I made it y equals. Second step, what's the main thing to remember about inverses? Switch x and y. I'm going to pause for a second. Find the answer. There is 2 ways to write the answer, but they'll be equal to each other. So compare with the kid sitting next to you once you're done. Don't just shove it in their face. Ask them, are you done yet? Once they're done, compare. I'll pause while you try that. Okay, so you should have said x equals 2y minus 7 and then solved it. Add 7, x plus 7 is equal to 2y. Divide by 2. Here's where you could do it 2 ways. I suggested yesterday you divide them separately by 2, but you didn't have to. You could have divided it all by 2. And there's your answer. Now, how do I know that's its inverse? Well, first of all, if I followed the steps properly, it will be. But how could I know? I could graph it and make sure it's actually a reflection. That'd be kind of long. The new thing for today is proving that, let's make this really clear, that the original, which was the red one, so let me get rid of that stuff, is really, don't talk please, a reflection, no, not a reflection, sorry, I got distracted, that the new one that we just made here is really the inverse. There's a way to do it with a rule. This is the proving rule. Is this really an inverse? Only if f of g of x equals x And the other way around, what do you think I'm going to write? Yeah, g of f of x is equal to x. If they are both equal to x, then they're equal to each other, and they are inverses. All right, so this will test, do you remember how to make one function eat the other function? I would characterize this next test as the easy part of this next test is just taking weird functions like f of g of x or f of g of 5. You know, things that are, you're eating one function which is eating another function kind of thing. That's the easy part. The hard part's the domains. Remember that domain formula we had to do? Okay, we'll practice that, but all right, so, and this is the other kind of hard part, but honestly, it's just the easy part. It's just you got to do it twice. You got to make one function eat the other function and simplify it down. And then go backwards and simplify that down. And hopefully at the end, the answer comes out to x on both sides. So would you please make the f function eat the g function? Now let's pick on f and a g. Let's say this is going to be f of x. And let's say this is going to be g of x. Because they obviously are the two functions involved here. So now if I was going to do f of g of x, I go 2 empty spot minus 7, and then you drop in the other function. Go ahead and do that and simplify it down and make sure that we didn't mess up. Do you get this as a way to make sure that the functions are really inverses and you didn't do some dumb mistake? When you only have 4 R3s, do you get it's worth taking some time to make sure they are beautiful? I don't know if you've processed this yet, but under our grading system, one of the easiest ways to get a good grade, you just have to get 3 out of 4 of the R3s right, because then you're guaranteed a 90% on the test. If you haven't figured this out yet, and say it again, if you've got 3 out of the 4 of the hard ones, you have a minimum 90%. Even if you make a ton of mistakes other places, in your R2s, you don't have to even get the R4 right, if you can get 3 out of 4 of the hard ones right. So that's what I'm trying to say is, well, wouldn't you want to like check to make sure you made your inverse right? You don't have that many hard questions. We have short tests, so be smart. Take the time to make sure you did it right. All right, so try f of g of x, then do the other side, g of f of x. Both of them should equal x at the end. I'm going to pause for a second while I give that a try. Okay. I'm going to put in the x over 2 plus 7 over 2. And if you had put that together and said x plus 7 over 2, it's all going to come out the same. Do you get there's an order to math? You can't just do stuff in any order you feel like. What would be wrong with saying, oh, I see a plus 7 and I see a minus 7, and I cancel them off? It's not the right order. Can't you subtract before you do what? Multiplication. This multiplication here is begging to distribute to both of them, and it actually is going to leave, it's going to mess it up. You don't want to do that. You've got to do it in the right order. Here's my point. A lot of times kids will go like this. Cancel, 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 cancel. Look, it turned out to be x. That is not acceptable work. Do you get that not everything in there even does cancel unless you do it in the right order? So I'm just trying to make the point that I'm going to judge you on this question, not based on whether you figured out it comes out to x, because you will figure out that it does come out to x. I'll even tell you the answer is going to be x. The question is, can you show me the right steps that make it mathematically turn into the x? Crossing everything off like this does not count. Okay, so what would you have to do? First, you'd multiply this times this and this times that. Well, what is 2 times the x over 2? It's x. Plus 2 times the 7 over 2. What's that? 7. And then bring down the minus 7. That was showing me that you know how to multiply first, and then you do the adds. And then this will definitely cancel that. And there's the final answer. There's work shown correctly. I'll do that again on the other side. G of f of x. Here's the g function. Empty spot over 2 plus 7 halves. And I got to put in a 2x minus 7 here. Here's work shown wrong. Cancel, cancel. Oh, cancel, cancel, cancel. The answer's x. Can't do that. Got to show me mathematically what happens. In this case, it's very common for people to think, okay, I think he always said to do multiplies and divides first, so I'm going to divide everything by 2. It would be the long, slow way to do it. Two fractions are things in parentheses, so you could add them together and it would be okay. Otherwise, you're going to end up with this nasty 7/2 fraction because of this part. Okay, so we're going to add these fractions together first. There's nothing wrong with getting a common denominator or adding stuff together. 2x minus 7 plus 7 all over 2. That's my first step. Now, again, kids will say, well, didn't you say that you always do multiply and divide first? No, I said do the order of operations first. Isn't there a parenthesis around the top of this equation? Did you know that about big fractions? There is. And therefore, I should really do the plus and minus 7 first on this one. All right, so final answer, those two, the plus and the minus 7 will cancel, and I'll end up with, can I just say x? No, that's the same deal. You can't just say cancel, 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 cancel. That's no such thing. But you can do 2x over 2, because those two obviously, one little step at a time, those two will cancel. And then, wait a minute, multiplies last? Yes, because this stuff was in parentheses. That cancels that. It does come out to x. Both sides came out to x. If this happens, then you've proved that they're inverses. All right, I'm going to give you one more. I want you to prove these two are inverses without any help from me showing all the steps. Okay? Prove those are really inverses. Or are they? You'll find out soon if they're really inverses. Let's say that you just did the test and one of the questions was make an inverse. And you were like, I'm not sure I did that right. I should check and see if they really are inverses. Pausing for a second. For those that were stuck, what we're trying to do right here is f of g of x and then g of f of x. Hopefully at the end, both of them will equal x. All right. Don't want to say names in the video. AC, could you tell me what you did for this first side, the left side? Awesome. So here's the f of x function, except I'm leaving the x empty. What should I put in there? Awesome. Next, should I cancel off the plus and minus 7, or should I cancel off the 2's? 2's. Because multiply happens here first. Then I have x plus 7 minus 7. I don't need to see any complicated work beyond that, because obviously plus 7 and minus 7 are gone, and it's just x. Yay, left side worked. Okay. CL, take over the other side. There. The way I like to think of this is, here's how I start with a g function that's empty, and then it eats this. So that goes here, just like you said. Okay, now what? The order is important here. Do the order wrong, get the problem wrong. Should you do the top part, or should you cancel the 2's? Do the top part, because there's an imaginary parentheses right there. Implied is the better word. Implied parentheses right there. Therefore, the top gets done first. Those cancel. 2x over 2. Final answer, x. Both sides came out to x. Therefore, f of g of x was equal to g of f of x. and they were both equal to x. Cool. What did I prove? They're inverses. Okay. All right, awesome. Next, let's do one where we have a function like this. And this. But these would have domains of all reals, which would make it just too easy. So we're going to use a domain on this one as x has to be greater than 8. And a domain on this one of x has to be less than 3. And we're going to see what happens when we take f of g of x and then find the domain of f of g of x. So two separate things there. First is just find this composition function. Find f of g of x. Then find the domain of it. Now, I don't want to tell you the formula. I will remind you in a minute, but I want you to try to recall that formula. It starts with domain of the inside one. See if you can remember that little formula for domain. Pause it. Okay. F has eaten G. Here's F. I make F with an empty spot where the X was, and it eats the G, which is that. Raise your hand if you had that one right. Okay, awesome. That's just the one function ate the other function. Okay, now let's get random person here. Let's see who the dice of destiny choose. Row 4. The last person. That's you. Do you know the formula? There's a formula for doing f of g of x.
Okay, domain of g.
Yep, domain of the inside one. Inside.
G of x in domain of f.
Now g of x, which is this, in domain of what? F. So that goes in here. Common mistake is people think that it goes in here. It does not. Okay, so then I got to do x squared less than 3. How many of you ran into that? You're right. That's good. I'm glad you figured that out. Okay, now here's a little bit of where, okay, the pre-calc isn't that hard. Up to here, it really isn't that bad. It's the algebra. Can you solve that? Here, are you just like stuck? Hint, square root of both sides. What's the square root of x squared? Not x. Absolute value of x. Important. I told you, I showed you on your graphing calculator how that's really true, and some people still don't believe it. Is less than square root of 3, because the square root of 3 is just the square root of 3. What are you going to magically turn it into two things? I know some people just slap in a plus minus right there. That's not right. Now I'm going to split it into two equations. Watch what happens. The first equation is that x is less than square root of 3. Does that look exactly like the original equation except without the absolute value bars? It is. And the other equation is x is, wait a minute, if I'm going to change this to negative square root of 3, isn't that going to make the sign switch around? Yes, it is. This blue sign right here is the key to not screwing that all up. I'll scroll that up a little bit. If I put that all on a number line, it'll make more sense. I know you don't know what the square root of 3 is, but you know that the negative square root of 3 is on this side, and the positive square root of 3 is on that side. And hopefully you know they're a decimal, like 1 point something. Couldn't be 2, because that'd be the square root of 4. It's got to be less than 2. All right, then it can't be either one of these, and then let's see which way they want to shade them. That says less than this one, and bigger than that one. It's in between the two of them. There, and if you just left it like that, then you missed the final point, which was we're supposed to be intersecting d of g with this. This is the right side of the equation. Now what happened to d of g? Domain of g was x is greater than 8. X is greater than 8. Now I go down here and I make, here's where 8 would be, and it has to be bigger than that. Where do they overlap? They don't. No solution. All right. You could even get this all right and do all that work, and it's just pristine and beautiful, but you don't even realize that this one can never work with this one. Okay, so once these two get overlapped with each other, hopefully you'll notice there's no overlap, and there's no intersection, and there's no solution. All right, that was a tough one. All right, so what are some other things that we've taught you? Tomorrow is actually the review day. Okay, so we don't need to review everything. I just wanted to do some of the tougher stuff. Tomorrow I'll have a comprehensive review day from beginning to end. But today, I want to give you your homework now, which is basically, here's 3 functions, and then some stuff to do with them, like make f of g of 4, or just f of g of x. And then their domains. I want to make sure you haven't forgotten the easiest kind of domain yet, and that's this. If I have f of x and g of x, what if I want to just do f plus g of x? Don't forget that that was a thing. So what are you going to do? Get a common denominator so you can add f plus g. Here's f. Here's g. I'm supposed to add them. I can't because they don't have a common denominator. So can I just leave it that way? Nope. You got to get a common denominator and add them. Put this over what? 1 to start with. Then, yes, we do want it to be over x. So that happens by timesing this side by x and timesing the top by x. This is why we make you do common denominators on the top 20. And some people are like, I don't need to really learn basic fractions. I'm in pre-calc. What am I going to use that for? Because we do basic fractions except with variables. So if you don't know how to find a common denominator with simple numbers, yeah, you're going to have trouble with this. Every one of the top 20 is like that. They're so important because they're going to come up here in this class. There's another one later this hour. Another one of the top 20s where if you don't know that yet, then you couldn't finish. Because, okay, so anyway, bottom line, learn all the top 20s. All of them. Get them down. We already had a test on that stuff. And even if we're done testing as a class, then you'd still have the option to retake all the way till forever. Okay, I'll pause for a second. And this is definitely a case of the haves and the have-nots in this very room. We have kids that have like 19 out of 20 in their top 20. They totally have it down. And other people that have like 10 out of 20, which means there's 10 weaknesses that you have somebody else doesn't have. Okay, so moral of the story, get that stuff down because this is where it gets you. Okay, enough about that. Then this becomes 2x squared minus 3x plus 1 over x. And now they have a common denominator, so I can actually put them together. So that means the denominator will be an x. Don't forget that when you're adding, you just keep the denominator the same. You don't like actually add x plus x. On the top, we add 2x squared minus 3x has to just add 1. It's as simple as you would think. Just put plus 1. There we go. There's your new function. That's adding 2 functions. What's their domain? Oh. Well, you take the 2 parent domains, domain of f, domain of g, and you just have to overlap those 2 number lines. Do you remember that part? So let's look at domain of f. What's the domain of this? All reals. What's the domain of this? X goes greater than 0, right? Okay. Then I overlap those 2 domains. Well, all reals overlapped with anything makes it really simple. So the other thing. So the final answer for the domain of this? That one. What was the one kind where we ended up with 3 number lines? We'll probably practice that tomorrow, but what 2 things can you do to the, or what thing do you do to the functions that causes you to have 3 number lines overlapped? If I did f divided by g of x. If I did f divided by g of x, then I'd have to overlap the f and the g, and then I'd have to also say, oh, by the way, the g function can't be 0 now. Okay, yes?
So is
You are correct. Thank you for catching me on that. I should have taken the time to do this right. The thing on the bottom should be set not equal to 0. You are right, not greater than 0, not equal to 0. Sorry, that does change my overlapped denominator or domain for these guys. So it's this, overlap with that. All right, one more quick domain. You'll be asked for to be able to find a domain, something like that. Do you remember what to do there? Don't set it not equal to 0. That's not it. Say it one more time. So tell me the exact equation to write. False. 2x minus 3 is? Good. And then you'd solve that equation and you'd have its domain. Notice you do not square root. You just take what's under the root. So then it's 2x greater than or equal to 3, x greater than or equal to 3 halves. So those little domains have to be like second nature now and easy. All right, last thing. Let's look at where the homework is coming from here. Oh, wait, no, there's one really important problem in the notes. If you've already downloaded the notes, get to this one. From the beginning of the hour, the goal was to just show you one new thing, and that was how to prove two things are inverses. What's the little thing you do? Put them inside each other. And then what are they supposed to equal? X. So let's just do one of the two sides. And remember, if it doesn't equal x, you don't have to go to the other side. So this is going to be the question is, does this just simplify down to just x? So f of g of x. Would everybody please figure out what that is? And if it could simplify down to just x. Beware, you're going to hit common denominator issues. That's where this class becomes pre-calc. That's why this class is tougher than a normal math class. You have to remember all that other math. Pause for a second while you find f of g of x. Okay, so when I did a quick cruise of the room, here's what I saw. People had this part right. A couple of them didn't, but everybody get back, make sure you're at least this far. That is the start of it. That's the f function, which maybe I'll write the f function in red here. Eating the g function. Now, what has to happen next? You actually add the top. In a fraction like this, there's parentheses up there, and it's basically, you got to add that all together first. 12-minute warning. I need a common denominator. If at least at minimum you could know that the 1 is a 1 over a 1. But then what do you do to get the common denominator? Pay attention, because this is going to separate the A's from the B's. Common denominator. What is the common denominator on the top? X minus 2. How do I get this 1 here to have an x minus 2 there? Well, you can just multiply it by x minus 2 as long as you also do it on top. Now, on the bottom, the common denominator also needs to be a x minus 2. Do all the multiplying all the way out, and if you do it right, everything cancels and you get x. I know that doesn't seem possible that all could simplify down to x, but it does. Take the time. If you can't do it now with like a teacher standing around showing you steps and helping you, how are you going to expect to do this on Thursday? All right, this is the part where I'd like you to confer with the kid next to you. And if you're like, I'm so stuck on what the next step is, check with them and see what they're getting for the top. maybe just try to get the top. Get the top simplified. Once this is all simplified, then figure out the bottom. And then you'll have a fraction over a fraction, and you can, hopefully, you know the fraction over a fraction is the top 20 thing, and you know how to handle that. Okay, I'm going to pause for a second while you try to work this on down to canceling so it just equals x. Pausing for a second. I heard somebody say distribute the 2. You're absolutely right. And then you get 6x plus 2 on the top. Once that, I knew that the denominator, the common denominator is x minus 2. I know that that's the denominator for this whole top. And now I'm going to multiply this out. And I get plus x minus 2. And look at that. It simplifies down a little bit. 6x plus x makes 7x. These cancel. And I get 7x over x minus 2. I know that's not x yet, but it's okay because the denominator will look a lot like this. And once you flip and multiply them, it's all going to work out. Denominator. 3x plus 1, there's nothing being multiplied or anything, so it's just that. 3x plus 1. Now here I got to distribute this negative 3 to both parts. Negative 3x plus 6 all over the denominator, x minus 2. Clean that up a little bit. 3x minus 3x. Oh, sweet, they canceled. Its denominator is 7 over x minus 2. There's the top, there's the bottom. Do you get why we practice this on the top 20? So that you know what to do when you have a fraction over a fraction? Because if you still haven't learned that, now you're so far behind, you can't simplify this. But if you understand that, oh, you just flip and multiply, I'm going to bring this down and go 7x over x minus 2 times, I got to flip the second one now, x minus 2 over 7, that's this guy, so it flipped. And look at that. 7 cancels 7. X minus 2 cancels x minus 2. My answer is x. Now, I'm not supposed to do that all in one step. So I'm going to do it one step at a time. I can cancel those because those are multiplies. And now I have x times x minus 2 over x minus 2. And then in one final step, that cancels that. And the answer is x. Just like we hoped. Really boiled down to you being able to get a common denominator. That's going to happen multiple times in this class. So don't just be like, well, I guess I'm going to get that one wrong. Well, then you're going to get that one wrong on like 5 tests. We have common denominator things that happen a lot in here. That's why it's in the top 20. Okay, so that's about as tough as it can get. And it does get that tough. This is not like an outlier, oh, they'll never do one that hard. Yeah, we will. You have algebra on this next test. I warned you. First couple tests are kind of easy. Not saying this is an impossible test. I'm saying, you know, this is where it steps up into like actual honors pre-calc level stuff. Now, what are your strategies? If you haven't been studying so far, what could you do to start studying for the test on Thursday? Well, I have homework that I'm going to give you. And I want to remind you that the answer key is not there yet. And tonight's homework is be the most important thing. It looks like that. It's a picture of problems. If you import that into Notability, you should be able to just write right on it and act like it's a worksheet. There's some good practice for tonight. Chosen specifically because you have to do that kind of stuff. All right? Notice they're asking for, when they say this, do you even know what that means? What's the word's way to say that? Find the inverse of it. Okay? Oh, if yours is upside down, when you import it into Notability, you can't take a photo in Notability and drop it into Notability? I'm pretty sure you can. Okay, I'm buying, though, that your solution is probably better. If you get into Photos, once you're into Photos, you can for sure do a rotate. And from there, you can send it to Notability. Awesome. I still have a theory that if you import it into Notability, I know you can put pictures in Notability. I know you can.
You can flip it.
You can't flip it? Oh, okay.
I want to do it.
So, I wonder how, here, let me see if I can post that better for you. So, anyway, the answer key will be posted later today, but I didn't want to have it there right away because I wanted to have some time to work on this in class without the answers yet. I'm going to post it very soon. Okay, there's your homework for today. And then what if you're getting scared about this next test? Just to clarify, when during the week can you see me? Mondays? Well, too late for that. Tuesdays? Too late for that. Tuesdays you can't see me anyways. But what you can see me is Wednesday during Mass, which is tomorrow, or Thursday before school, which would be 7:05. You could come in and get help both days. Because the test is on Thursday, you could come in Wednesday during Mass and Thursday. I'm not saying you should. I'm saying if you're scared, if you want to do extra work to study for this thing, that's how you can do it. Okay, that's all I got for you for today.